And hopefully, I will leave myself time to also talk about installation. So my plan is to take around 40 to 45 minutes of presentation, leaving 15 minutes of question and answers. See how it goes. So PolyCAD is not my day job. This is all done in the background, but a lot of my career has contributed to it. I happened to start out in university. I got a job for my first year working on a crane project, a control system. But then I went into the world of consultant naval architecture. In Europe at the time, they were doing a lot of work upgrading the typical ro-ro ferries after a lot of the stability or incidents that we had had here. So there was a lot of simulation, a lot of calculation, a lot of model tests, and this went on to create changes to ships, and obviously these had to be refitted, and I followed the entire process. And this really is where kind of PolyCAD came into its own in generating a lot of the data that was used primarily for the simulations that we were doing, based primarily on sections. And after that, since I was interested in software, I found myself programming an evacuation simulation, again for the University of Strathclyde. These were emerging regulations coming out of the IMO. And to test the software, we also did a few experiments on board cruise liners. And this is some photographs from that. But around this period, my ability to work with software was really emerging. I kind of created some maneuvering simulations for certain projects, so I was getting into software. So really my first run of software companies with a software called Paramarine. This is developed not very far from where I live. This is very much an unusual piece of software. It's coming probably from a more academic perspective, certainly focused towards naval ship design. And I have to say, primarily in the UK, we have a very limited amount of commercial ship building. So all of our shipyards are primarily focused on naval ships. So it's expected that projects here would be naval. But I was bringing a commercial focus to this. But you can see from the images, this is a very conceptual design tool where they're looking at requirements and trying to figure out how the design should be configured to support those requirements. And then following that, I had the opportunity to work with, for most of the time that I worked with them, the market leader in what I would call the big ship production software, Aviva, formerly Tribon, initially in the naval architecture side. But as I went through the process there, I learned all about the hull production, outfitting design, getting into how things were produced in the shipyard. And I contributed to a number of projects that were built in the UK. I think the aircraft carrier, bottom right, is the biggest one. They built 2 of them in the UK. But the smaller ships I've always found more interesting because you have to fit a lot of kit, a lot of stuff into very small spaces. And that's always an interesting challenge, whereas the aircraft carrier just has a lot of space to figure out what they're going to do with it over its 50-year lifespan. So it's prepared for the future. But I left Aviva a couple of years ago, and I've ended up doing something slightly different from ship design and production. I'm now working with information management. This was a topic that kind of became more important in my time at Aviva, but they didn't really want to focus on this kind of solution. So this is really about how can we bring the data together from all the different design systems, all the documentation, and when you bring this all into the same environment, then you can start to do a lot of the management processes on top of it. So it's a web-based solution, so you can deploy it around a shipyard, around a design office, but you can deploy it out to customers, subcontractors, and you can get everybody to work together. So it's very much a collaboration tool, and you can start to report things on top of the 3D model, which is what you see on bottom right. So the upturned double bottom structure, green and red, is indicating parts that have been cut and parts that have been nested. And the piping system shows different areas of work packaging. So this has been very much what I do in my day job. So let's move on to PolyCAD. So the origins of PolyCAD go back a long way. I seem to have been interested in computers for a long time. In fact, probably given the time I've spent on it, I've probably been more interested in computers than shipbuilding, but always the software was something to do with shipbuilding. And back in the early days, programming Windows software was actually quite hard. It's become a lot easier. And you can kind of see that even without nice graphical solutions we have today, what you can come up with was kind of functional, but not very pretty. And then following university, I had the opportunity to start to work on some projects. And typically these were, problem-solving projects, trying to do seakeeping in this particular example. So we have the small shuttle barge offloading into a large large bulk carrier at sea, needed to do some seakeeping calculations. So how do I manipulate the data? There wasn't really the tools available that I wanted to do that. And then subsequently, if you remember, I talked about upgrading the ro-ro ferries for the North European fleet. Again, we see the use of sections. These are very versatile representations for hull forms. They can go easily to calculate the sort of hydrostatics and stability, but it's also what a lot of simulation programs use that deal with hydrostatics, internal flooding. So PolyCAD kind of started out under the PolyCAD name as a tool for working with sections, creating compartments that you see top right, for doing these kind of projects. And it did save many, many hours of what my colleagues were doing originally, is typing coordinates in text files. So crazy stuff. But personally, my interest has always been around hull surfaces. So as much as sections are really important and still supported today in PolyCAD, my focus has always been hull surfaces, and very much focusing on the actual personal experience of creating hull surfaces, either for design or for definition. They are slightly different activities. Most of the early focus was around B-spline surfaces, which you may have experience of. We'll talk a little bit about that later. But for me, I was more interested in rapid approaches for creating high-quality surfaces. And for this, we turn to techniques like parametric hull generation. That's what you find yacht lines and ship lines, which are tools inside PolyCAD. And then kind of heading for my PhD, I wanted not just parametric, but to have some interactive definition. That's what became of IntelliHull. And following the developments of IntelliHull, which was very much an academic study, still, that wasn't good enough for what I wanted, and ultimately, that's where X topology has come from. We'll cover that in the second half of the presentation. But it's still important that we have those foundation representations, because sections, they come in table of offset books. Sometimes you find sections in files. Sometimes you find hull forms represented as polygons because some weird software has ended up capturing the data that way, typically in sometimes the boundary element data that you get in CFD type applications. Maybe the original definition isn't available, so you only have available the polygons. So you still want to use that data, and PolyCAD can extract and do stuff with that data and turn it back to a hull surface if that's what you want. So yes, here you would see a typical B-spline surface representation, and we have the marine representation of contours, but also the curvature analysis on the surface, which is kind of on any surface in PolyCAD. But then focusing more on ship design, there's lots of elements there. So we've got quite a lot of the core analytics, so it's hydrostatics, stability. We go into the arrangements in terms of having tools for creating the frame ruler, subdivision. There are various combinations of compartmentation and tools as well. I introduced a few years ago resistance powering tools, one for yachts, the Delft series, and Holtrop and Menem for ship powering. There's, of course, basic geometric analysis like the extent, areas, and volumes, drawing generations, so drawing generation of lines plans, export of offsets, support for laying out designs, talk a bit about that in a minute, parametric hull generation. So quite a lot of specific tools for marine design that you wouldn't find in kind of mainstream tools, because a lot of these things are little tools that maybe take a long time for me to create, but just generating that data, sometimes these days you're turning to Excel to present it or other types of tools, and this kind of speeds that whole process up. And then focusing on the sort of productivity within naval architecture, I spent a lot of time on projects kind of turning lines planned into hull forms, offsets into hull forms. So, also so many plans available on the internet, but they're all captured as images. So there are tools to present them in 3D and turn them back into a hull surface. Similarly, we can do things with laser scanning. So I created some tools for that a few years ago, and certainly also support of a lot of popular file formats to exchange the data in PolyCAD to other systems. So what does PolyCAD today represent after 25 years of development? Well, I still try to keep it simple. The data file remains text-based, so that if you want to go and edit the coordinates in a text file, or you want to read them into a simulation system that you're making, well, you can do that. You can open up the text file and see how PolyCAD works. It's always got numerous functions for more productive geometric manipulation and analysis. But this is where things start to stop. I'm not supporting things like solid modeling because it's a lot of work, and I don't want PolyCAD to be a full-time job. And solid modeling is a very complex area which would require not having text file-based models and things like that. So there is a limit to what PolyCAD does. It's been going for a long time, so most of the code is in a very high state of maturity. And for the last few years, I haven't been changing it, although PolyCAD 11 is coming, and that does have a lot of new features. So a lot of small, powerful details. And I guess a question that might come up is, why isn't it a commercial system? Well, these are interesting rules. Commercial systems must make a profit. And if you're profit-driven, then that's going to influence your development decisions. And that often means you cannot investigate interesting things because really you're driven by the commercial aspect of the software. So I've kept away from that. That means that PolyCAD has got a lot of interesting tools, but I'm also limiting a lot of the capability so that it does not try and compete with a commercial system at a free level. PolyCAD is free. So I want it to remain non-commercial, but life gets more expensive. So we see how it goes. It's my intention to not continue to not charge for it after 25 years. So maybe we have a look at the software itself. I thought I'd start by a quick review of what it can do so you can see the breadth of it, and then maybe look into some of the capabilities. So you come into a typical CAD program screen. We got X, Y, and Z. And from here, we've got curves. I'm not sure whether I can hide this. I do remember there was a way of getting rid of that, but there we are. I'm going to stick it over there. Does that help? So if you can't see my screen, let me know. But it's a modeling tool, so we can go away and draw curves. We can get directly to the curve positions. If you press F2, F2 is the main edit key, and you can go and manipulate these curves. It's straightforward. We rotate, we can see we've got a working environment. And the working environment is quite special, so such that if you start to work in 3D, you're always working within a 2D plane. So this means that if you create information there, it's in a plane, much like if I started to, and we have the snapping function. So if I started working on this point, I know that the cursor you can see says a YZ, which is a section plane. Everything I've drawn in that section is on a plane. So it means that for a ship where you're typically working in planes, buttocks, waterlines, and sections, you can look at it in 3D, but know that you're editing in a 2D plane. You can turn that off, but most of the time that's probably consistent with what we're doing. I'll get to some of the other curves in a minute. We have surfaces. So if I just draw a surface, you see from much of this, a lot of the interactive features are quite basic. And you can, from this surface, analyze it. So if we wanted to analyze kind of the curvature, and we can start to look at the lines. So these lines are much better when they are smooth. If you get a corner in a line, you have a break in second order continuity. If you get a break in one of these lines, then it's a break in first order continuity. So it kind of gives us feedback. And we can also get our contouring information. Let's go with those. So turn off the surface, then we can get the information like that. Edit our surface interactively. We can see things changing. And we can also start to access the surface in terms of its rows and grids. And obviously for a complex whole surface, that makes life much easier. So everything I've shown very now is kind of very generic. Let's delete that. We can immediately, for example, go to, say, a yacht hull form. And I'm going to be using a lot of yacht hull forms in the presentation just because they're quite quick. But I would say PolyCAD is a lot more powerful, but we've only got an hour to work with. So we've got a very simple yacht shape, and we could start to bring in the hydrostatics. So we can select that. We have a draft. We have a center of buoyancy. We can start to modify that. So if we went something like 1.2 meters, we have an implied hull form. I mirrored it there. You can start to see kind of the shapes that we're working with. From here, we might go on to, well, why not bring in the section area curve? And what you can see is from a design perspective, I'm going to pop that down there. And ultimately, this is my approach to design, that you can start to edit things and start to see all of our properties changing. So section area curve, our displacements are changing as we start to edit the thing. So you're getting that immediate feedback. Of course, the more complicated calculations really aren't intended to be interactive. So if you wanted to go on and say, look at a floating position, then we can start to do analysis here. We can get our GZ curve. It's a bit of a strange one, but we can start to see how the vessel performs when it's heeled. We can get access to, there we are, information about the draft, and we also see how the draft is calculated. So draft is being calculated between the implied baseline and the plane. It's good information to know, kind of giving you information how the whole process works. So as a breadth of things, you can kind of see where we're going. I talked a little bit about internals. So if we just turn these off, we could go on and create some bulkheads. So let's create a bulkhead at 2.5. If I put this within the hull, it should automatically calculate. Yes, I always get trapped by this. I have to go and edit it. And then our bulkheads within the hull. If I was to do a deck, say at 3.5, then I could put that within the hull as well. I think it was a bit high. So let's bring it down to 1. There we are. There's our deck. So you have the opportunity to build a bit of subdivision. You don't have the opportunity to create compartments interactively in PolyCAD. It's coming in a version of PolyCAD 11. In previous PolyCADs, this has been macro-driven. So this kind of gives you a breadth of the types of things that you can do to build up a layout. There's quite a lot of analysis options. So we could be going into doing some analysis on it as a yacht. So we could go into the Delft series. Not sure why it's not giving me that option. It's probably something straightforward that I haven't thought of. So let's get into more of the way that PolyCAD kind of works. So curves are a big thing. Not just polylines like I started with, but you've all got all types of formats of curves. And although curves might seem quite old, they're really important for maybe sketching out designs. So for example, you could use these curves to sketch out the extents of your ship, for representing decks. And here you can see a wireframe of the hull form behind the scenes as well. As we get later, you'll see that curves come ever more powerful for creating surfaces. So if I start with a plan view. So just to kind of show the capability of the way that PolyCAD works, I just click on a tool and start drawing. And we use F2 once it's selected to start to manipulate things. You can, of course, delete, but you can also press the A button to start inserting points. So as a way of adding, deleting, and refining, you can also see we've got feedback on curvature as we're being interactive. It's trying to be as interactive, giving you feedback on design as you go through. There are quite a lot of options for curves, arcs, circles, polylines. One of the nice things about all the representations that I've chosen is that they can all be converted back to a B-spline representation. So you have a consistent curve format for many of the operations. So leading up to kind of where curves are important in the hull design, kind of in a section later, I created an interactive surface earlier. Maybe that was enough to talk about the surfaces themselves. The reason why I kind of popped that in is that most people's experience of surface design is manipulating a B-spline surface. It's the first thing you do. Often it's just that easy thing that you learn in one of the first pieces of software you get hold of. So maybe talk a little bit about it. So using the B-spline surface and using that yacht hull form, it's just adding a bit of points. It's something where we can just effectively drag and drop our design around. And it's so easy that I think a lot of people in the first years of their kind of experience with naval architecture think that this is the way that a lot of things are done. However, designing with B-spline surfaces is actually very hard. You get the impression that they could do anything if only you just spent a lot of time with them. And that's not necessarily strictly true. They have a lot of mathematical limitations, especially around curvature continuity. That's one challenge. And the other challenge is that actually when you get into shipbuilding in the shipyard, the level of accuracy that you think you require really isn't necessarily the case. In actual fact, a lot of ships get built with some quite poor surfaces. So talking up the precision isn't really a reality once it actually comes to doing things. And creating complicated surfaces by manipulating all these surfaces is incredibly time consuming. So it's easy, but the reality of it is that commercially, this probably isn't the best way of doing things. Hence, we'll talk about that in a minute with PolyCAD. Since this is, as I've said, a potential slow way of doing things, there are other ways of building up hull forms using simple curves in PolyCAD. So for example, we could build up a chined form. And there are quite a lot of other surfaces that I would call constructive surfaces. So we could use a ruled surface. I need to select them first. So we simply create a ruled surface between two curves. So this is going to be a hull form with two chines, like so. So now we have a hull surface. This works slightly better if I put it in a perspective view. And using these curves, we can manipulate them and actually get the surface to change as we do it. And even though it's three separate surfaces, there are tools to just have a group. And we can get rid of, we just hide the intermediate surfaces, and we can work with the surface as a whole, turn on some contours, and it behaves exactly the same way as the other surfaces we've been doing. We can do hydrostatics on it in exactly the same way as any other surface. So there's a lot of constructive tools in PolyCAD, say for chines. There is also another thought that many people get when they're working with curves is, if only I had a set of sections that I could put a surface through it. Well, it kind of works, but when you get into the details of ship production, this is not good enough. So here we have a set of polylines. I could do all the calculations with just these curves. As I said, we support sections. But perhaps to illustrate some of the challenges of working with curves and just working with generic surfaces, there's a version here that's been turned to curves. And the reason for putting this together is that ship surfaces are quite complicated. They've got flat parts and curvy parts and areas around the bulb where they're quite sharp curvature. And if you try to do this all in one go with large representations, well, they don't behave very well. So you can see here the curves. Curves are not behaving well because all of the points are distributed in a very small location. So depending on the curve, the mathematics can become quite unbehaved. But even so, you can still put a surface through these. Where's our lofted surface? Like so. And you can still get a surface representation. Now, it took me less than a second. And if you need to do a quick calculation for some volume or stability, this might be good enough. But, 1 second of work doesn't necessarily give you a high quality surface, even though if we look at the contours, at this stage, it might not look too bad, but look into the details, it's quite poor, and it hasn't captured properly the flat of side, flat of bottom. So there's a lot of challenges with these kind of big algorithms for fitting surfaces. We need something more specific. So that is ultimately where we get to with X topology. But prior to X topology, I talked about in the beginning creating tools for PolyCAD that were all parametric, and these are they. So let's have a rendering of that. So these are all driven by numbers. There is no points to manipulate. So this is also a very quick way of changing things. You can just type the values, and we can see the areas of the vessel changing. Let's have a 10.5 waterline length. It might not always behave as you expect because you're asking it to do things sometimes that it cannot do. Let's go for 0.5 forward overhang. So you can change things and get different shapes. Similarly, there's ones for ships as well. So you can manipulate the parameters to get close to what you want. You can turn bulbous bows on. And if this is good enough based on the numbers you need, then it's probably taken you about 5 minutes to generate that surface. It's not taken a lot of time. So it can be quite powerful in generating surfaces for your work. However, let's talk about what we really have to do in commercial ship design and naval architecture. So the challenge is really one of how much time can you spend? A surface representation is required to do the work, but often the work that you need to do is not interested in the surface itself. So compartmentation, you need a compartment model based on the surface to do damage stability. If you're modeling hull structure, you often need the hull surface to begin putting in the structure on the inside. If you're doing hydrodynamic analysis, you require the surface to work on. So it becomes a requirement, not part of the job. And it's not until you get to things like powering optimization or dealing with the styling of a vessel, if it's like a yacht, a mega yacht, that there is some value in spending time on the surface. And this is kind of one of the strange things about our business, is that hull surfaces are very important to what we do, but not a lot of people really take the time to understand how to create surfaces efficiently. And often the task is given to the person in the office that is prepared to do it, which is a bit of a shame. That was normally me. So the problem is that creation of a hull definition is often perceived as an overhead in a commercial project, unless the performance of the surface is a factor. And that means that it's always been a challenge to find or understand how much time is required to create a good enough hull surface. And actually, good enough is a bit of a problem because depending on what you're doing, good enough changes. If you're just doing a stability analysis, a hull surface can be quite poor. Maybe you're not worried about the smoothness of the surface. If you're doing a proper ship design, then you're going to worry about that. So how much time you spend on the surface can be important. And as I started to allude to in some of the previous stages with PolyCAD, hull surfaces in reality have quite complicated shapes. Yachts are kind of curvy, but once we get to ships, we can have a lot of chines, flat areas of high curvature. And also in my experience, you also find that sometimes to get the surface to come out right, you do need to incorporate some of the production features. So things like the way that a stem bar flows around the bow can actually help the way the rest of the shape of the surface works just by the knowledge that it has to be there. Sometimes a naive surface, a surface without these features, doesn't come out right. And you might struggle for hours, days, trying to get the shape to really come together. And where I'm going to this kind of to some extent seems to be quite against the way that software has gone. So often curves have been perceived as quite an old technique. more closely related to 2D or technical pens or lines plans. But what I want to show you is curves kind of give you a freedom of design that you don't get with surfaces. Surfaces are quite complicated. A lot of the ones that we deal with have this rectangular definition. You get involved with the topology. And speaking mathematically, surfaces blend two directions of curvature together. Now, blending is another word for averaging. And when you average data, sometimes you start to miss or hide poorness or inconsistencies in the data. So surfaces, you might see a surface not behaving well, but not knowing why. And there are other elements of surfaces that slow things down. You've got a lot of precision. They are tools often for solid modeling. So when you're kind of free-flowing in design, surfaces can be a constraint. I'm not saying that we should abandon them, but when you're designing, they kind of get in the way. So I've ended up going much more towards an old technique, but I've updated it, which I would say would be called digital lofting, which allows you to use curves, but without having to focus on the surfaces. So this frees you from that surface constraint. And because it doesn't use blending, it's very good at showing you where there is inconsistency in the curve definition, and this indicates unfairness. So show you how this goes together. Typically, in a lot of ship design software, you use a curved network to generate a surface. And that is the end of the story. If the surface isn't good enough, you modify the curves and you continue to iterate until you think it's good enough. I have an alternative or parallel strategy where you can use the curves, the same curves, to create a lofted surface. And the lofting process often shows you whether the definition is behaving poorly. But you can still create the surface at the end of that. So this helps you create a better surface as an intermediate step. And then potentially as a final step, you get to combine the two, and this actually can build a very powerful, very smooth production surface. The fitted surface is not something I'll talk about today. I'll talk about the other two techniques, since we've only got a few minutes left. So let me show you the more detailed end of PolyCAD. So this is all found in the X topology surface modeling. If I sketch a curve, it's going to be a ship section. You can see it starts life as something that behaves as a B-spline. Now, typically when you create a B-spline surface, you have to manually introduce all the features, either by manipulating the knots or the points. But these are special curves such that if you wanted, say, build radius, you can introduce that as a blend. You can perhaps go on, same idea, Control A, you could add a knuckle. So we have a toolkit here that gives us a lot of tools for creating tangencies, interpolation, and other features on the curve. So the software is doing that work of manipulating the surface for you. So as I said, this is going to be a ship section. I'll place it. And this is 0, 2, like so. So it could be our main frame. Let's place this at 40. And we'll create a parallel middle body. So I'm just doing a copy and translate. So two ends of our main curve. And now I'll sketch in the rest of the whole surface. So I've got a network of curves. Let's produce a surface. And we're starting on our trip to a typical whole surface. Now, what the system is doing is figuring out from the curves how to build surfaces up from that. So far, I haven't manipulated really any detailed control points, and immediately I've got the shape that I want. So I'll add in some more shapes. Let's add in our profile. Let's make that. I want the other way. So kind of a bulb. That is going to be an X. So you can see we can start to build these features. Now we need some more points to build a typical bulb shape. Let's build a deckline. Of course, we have flat of side, so we can make that a straight, and we can tangent into the bow like so. And we will probably, if I add a Z plane, so this fixes the curve in a plane, we can now make the shape a little bit more detailed. We're also in the position now to add flat of side. This will be a Y, and this is a frame, so it has a frame-like behavior. Yes. So it's enforced tangency on its curve, on the curve there, to be straight. Flatter bottom. It's done the same, but it's kind of wrong shape for a flatter bottom. So we'll add that shape in here. So even at this stage, I can probably turn this into another surface. Might not like it. I have a feeling it doesn't. No, it's too quick yet. I'll add in some more features. So typically we can then, yes, these are parallel. So these create the planar shape. And this is in fact not a plane. There we go. So from here, we could add further curves in sections to build this up. And I am going very quickly, so please don't think that this is a beautiful whole surface. But you start to get the idea of how the process works. In fact, we have a waffle shape. That should in fact be 12. There we go. It's more like a ship. The challenge now is that we need to add the waterline information in a mesh, and you can kind of see that happening in there. So I know that I am running out of time. What I want to show you more is I spoke a lot about using the lofting mechanism. And what I want to illustrate that lofting actually can do a lot of the hard work for you. So instead of using a lot of curves, if I just put a loft around this, you can see that with no information whatsoever, it starts to build what I would consider a reasonable shape. Now, there are some rules to this of how it builds up this shape. It starts with the first set of curves, which are waterlines. In this case, its second set is buttocks, but I want to go with sections, and it will finish off with the waterlines there. And from here, I could put in, say, a waterline around here. Add this to the loft and start to manipulate these curves. Actually, now I want them to behave as sections. So you can see now we have a much more powerful way of designing the surface. And I can pretty much do whatever I want. I can put a curve in anywhere. and the system will start following it. And I don't need to worry about where my surfaces are. So what I do, I use these process to get the hull form right, and then finish it off by creating a surface like we do there. So there's far more tools to build up a good shape in PolyCAD this way than there is in a lot of commercial systems. Okay, I'm going to give you a bit of time for some questions. I will say you can find PolyCAD on the internet. It is a free software on polycad.co.uk. There is a downloads page. I recently introduced online web registration as opposed to email. There is a video that shows you how to do that process there. One of the reasons for introducing the online registration was that there were so many academic students using PolyCAD that I felt it was far quicker to do it that way. Anyway, I hope I have not gone too fast, but I'll open the floor up for any questions.
Well, hello. I actually do have a question. Do you have like a platform, or I don't know, maybe it's an idea for like a course? Like, for example, as you mentioned, like the part where you use the mathematical method to create the part of the bow.
Mm-hmm.
Do you have like course or something related like that?
Not a course, but you will find lots of videos on YouTube on how to use. So there is a YouTube channel. I'm slowly adding videos to this over the years, but you can see they try to show you lots of different ways of using PolyCAD. Some of them are quite old, some of them are newer. Some of them have, say this one here is a really basic tutorial for, and a video plays soon, hopefully. Right, there we go. So this one, for example, shows you the basics of X topology, and we're going to build, say, a canal boat. Canal boat is something that looks like this on the canals in the UK. These days used a lot more for leisure, but they were commercial boats in the old days. And it just takes you through that process of drawing that up, and you get the experience of using the curves. So there's a few of them getting slightly more complicated, working with curves. So not necessarily a course, but a little introduction to how to use the software. So there is a raised hand.
I think you can turn on your microphone now.
Okay, can you hear me?
I can hear you.
Yes, I will ask you for the compatibility with other programs like AutoCAD, Rhinoceros. How can we export those surfaces in a universal format like IES? I was looking in the web.
You have a lot of formats there. Actually, my license has decided that it's not going to update. I actually know that that's a bug, but there are lots of import formats, probably more import formats than export formats. The critical ones are, you're exactly right, AutoCAD DXF, IJs are pretty much the ones that you would mostly use in ship design. And there are some more specialist software accessible there. So it should be really easy.
Other question is that if you will in the future release the code like make it this project open source, or
I am not sure.
Okay.
The reasons for that are to do with what has happened with other software. So you might already have experience of Delphship, which was formerly FreeShip. And at a certain point, FreeShip was released as open source, and then someone in the Far East took the code and incorporated it in a commercial system. So I did not think that was very fair. So at the moment, I'm not planning on releasing the code. A lot of that is down to I have so much fun with it. I have so much fun with it. I'm good as it is. But if you wanted to know how to do something, I'm more than willing to share my methodology and help you build your own or share code. It's not a big deal.
I think there is another raised hand, but someone.
Good afternoon, Doctor. Thank you for this position. I have one question for you. Sorry, what are the criteria to analyze the stability or the line plane design to the ship? Exists another option to set up this, or not in the software?
No, this is all. So the analysis gives you that aspect. I'm going to save this file because so I can get to a different version of PolyCAD. So I will just call it demo. Currently, my license system doesn't like me having two versions of the same software at the same time. Or I might have broken it. Okay. I will show you with this example. So the way that I set up the toolbars is that often you get the creation and then you get a lot of an analysis towards the right-hand side. But all the analysis options you will find on this area of the toolbar. So selecting any surface or any hydrostatic element, you can get access to hydrostatic curves, cross curves, floating position. It just has to be an element that supports that kind of capability. So here we're into the stability, and you can calculate the GZ curve. So the only criteria is that the element that you're focusing on can support that type of calculation. It's the same with the lines plan. If you can do the analysis, so we will need a few more contours there. So we step 2. It's busy. This is currently PolyCAD 11, so it needs a lot of testing right now. So might have a few bugs. But accessing these elements is normally straightforward. You just click on it or select it, click on it, and it enables the tools up there.
Yes, doctor, but I refer to the values for the society of classification that we have to do respect to these values to accept the design of the stability of the shape and
okay. So this is where I am a bit careful. Once you get into that type of analysis, typically it's commercial. And since you are doing a commercial job, you should pay for the software. So I'm not trying to deliver software that could be used for everyday commercial activity. There are the other companies out there do that commercially, and if something goes wrong, you pay them for support and things like that. So I'm being careful not to create a system that, or sorry, a piece of software that undermines the commercial process. So if you want to get that information out of PolyCAD, you have to do a bit of work. I'm not trying to support commercial processes. I am much more trying to support sort of learning processes that students experience, and things like that. So it's a different style of software than many of the commercial tools, and it's more about learning the processes and being able to manipulate them.
Thank you, Doctor.
You understand where I'm coming from in that respect, yes? It's free, so it doesn't try to do
Yeah.
what commercial tools are trying to do. Get rid of it.
Are there other questions?
I saw
Okay.
a hand just come up.
Yes, I will ask to know, just for curiosity, what was the programming language that you used to do this project?
Sorry, I didn't catch that.
The programming language you used to do.
Oh,
to
Delphi.
make.
Delphi.
Oh.
So it's a modern version of Pascal. It has, well, I use it quite frequently for other work, but it's a really easy language to get integration with Windows, with graphics, with many other tools, and yeah, it's been a library that's built up over the years. There is a community version available of it, so you can use it for free. But the principles are Pascal, but it looks a lot different to the traditional Pascal of 20, 30 years ago.
Marcos, can you hear me?
Yes, I can. Go ahead.
Can you hear me?
Yes. Yes.
A couple of questions. My name is Jose Marin. I'm a faculty here at the Naval Engineering Department. When you generate the surface, right, you can calculate a curvature.
Yes.
Is there any recommendation in general so we could, for example, decrease the curvature in order to reduce the amount of work that you have to do bending the plates or something like that?
I have not found anything. I am probably one of the few people that have had the opportunity to work both with the design software all the way through to the production problems. Typically, there are very few people in the world who have had that kind of breadth of engagement. I have not found any helpful information on that. What tends to happen is that once you get into production, people just try to make what they're given. Now, that might mean that it just gets more expensive, but it seems that it's very rare for production to feed back on what they are capable of building into the design process. And
Okay.
I have been quite disappointed by that, but there seems to be nothing I can do about it.
Yeah. It's a big problem because people in the design office can generate anything, right?
They can.
Then when you try to build it, it's something quite different.
Yes.
Yeah.
And typically, I mean, the problem is more of one of human organizations, is that the production people are often so far down the line that them complaining about it doesn't help.
Exactly.
So they just try their best. Now,
Another thing.
Yeah.
I'm a faculty, and I'm always trying to understand a little bit more than just using the program. If we would try to prepare a course on computer-aided design, right? What elements do you think we should include? For example, in any of these theories about B-spline, curves, surfaces, and things like that, or we should go directly to more use of software or something like that?
Unfortunately, I don't want to say it, but I think that you should go more towards the use and the application.
Okay.
The reason being is that if once you get out into the real world, that helps you quite considerably if you have insight to the way that the software really works. And you might need people that do those kind of commercial projects to come into your faculty and actually give you more insight, because finding people that actually do the work is not so easy. They might do the work, but they might not get the opportunity to talk about it. I guess I am quite interested in the theoretical side, the other side of it, which is important, but there are not many of my type of people around. Let's put it, I'm the ship nerds.
Yeah. But the thing is that I can see these surfaces. See, I did some of this 20 years ago. And yeah, I interpolated very rough surfaces with B-spline surfaces. And it was fine. It was fine. But the problem is that if you want to use it effectively, you have to understand a little bit about how these things work.
It's very true.
So yeah,
and I think that's really important, but I don't know how to communicate it. I would say what we're talking of. So 2007, I was really deep into this, and I found I pretty much got to the limits of what surfaces could achieve, and that gave me the opportunity to have some quite good practical knowledge about what people should do. But I think subsequently I found that not many people were interested.
Mm-hmm. Okay.
So there's a lot of knowledge up there.
Yeah.
I'd love to get out someday.
Thanks a lot. Thanks a lot.
Thank you. Okay. Keep the questions going.
Thank you so much. It was very educational and interesting presentation. I just one curiosity. You show us the possibility of importing a file from a laser scan. So which type of file is it?
So currently it supports text files and E57. So E57 has become quite a more popular format. It's a digital format. So it means that the data is far more structured, but you can import text data as well. And the text files can be quite big. So the first file I ever dealt with was 11 gigabytes. You cannot load these files up into a text editor to see what's in them. I wonder if I have a file on my laptop. That's not guaranteed because they are very large. We have a laser. We have E57, so we might. Tornado is a good one. I'm trying to see what the original data was. And I might not have it because it is some of the time huge. Let's see what the PLY was. Okay, so you can see this starts by giving you a preview of the data. And it's found another bug, so okay. And it allows you then to go through and start to pick out the columns, what you want to do with them. So it processes that into the kind of the data streams that you want. So in a laser scan file, you would typically find the XYZ coordinates. You might find a color in terms of RGB. You might find a color in terms of the intensity, 0 to 1, or 0 to 255 in terms of the point brightness. So that gives you the ability to show that data there. E57 is a bit different because everything is defined in the file and you don't have to convert the text to something meaningful in terms of data.
Okay, thank you. Thank you so much.
I will hazard a guess at trying to load a laser file. Let's see. Again, not guaranteed that it will work. Here we are. So you can see the laser scan point data here. It's only showing you 10,000 points of a lot of data. It doesn't seem to have any color data in the definition. Let's see what else we've got. This is the tug, so the entire data set is there. I have a feeling this did not come with any color. It's interesting that you might assume that the more data you have is better. If you're creating a whole surface, not necessarily, because sometimes you can overdo the amount of data that you have and it's not actually contributing anything. But the nice thing with cloud point data is that you can look at the overall shape, but then you might want to go in and look at, say here, looking more detail about the format of the anchor pockets. And then you can dig into that. So you can extract different resolutions of data based on the detail you're working with. You kind of have to keep the point cloud data moving to see what's going on. So what I do with go on.
Now I have the curiosity, how did that scan how the scan was made? Because the ship is like kind of floating, so all the other I don't know things are around. How it's
typically the ships aren't floating, they're in dry dock, but you actually have one of the points, as you can see here, that when a ship is in dry dock, then you actually have some areas of the ship that you still can't scan. So a lot of the keel blocks and a lot of the supports, and that's a challenge. What I've done in my software is it doesn't mind if the data is not there. When you start to fit the curves to make a surface, if the data is not there, it will just ignore it. And it just kind of predicts the shape that it should be based on the missing data. Obviously, if a lot of data is missing, the prediction or the estimate will be poor, but it accepts that the reality is that ships sit on the bottom of a dry dock, and it works with that.
Nice. And once we have the ship there, we have just to put lines, like the software does that, or we have to draw?
Yeah. So I think this is from a conference. So the challenge is often finding what I call the topology. So definitely the stem and the other shapes, but typically you can kind of see them. So if I hide that one, and we get some of the sections up, I don't know what they'll be showing. Let's get another version of this file. I think trying to find the biggest one. I assume that's got everything in it. This one will take a little bit longer to generate. Hopefully it's got lots of data in it. Yes. There is some videos on the website that covers this process. Goes into a lot more detail. And as I said, there is a lot of data. So when it comes in, so you can start building sections from the point cloud like that. So at a basic level, if you just wanted to draw over the top of those points, you can do. That's the simplest way possible. But then what I do is using the curves, and I think being careful about not presenting too much data. But these curves are fitted to the point cloud. What it does is it takes a plane, it samples the point cloud to find data points. I will have a go at that. I'm not guaranteeing that it will work. I have not tested this at all. So let's do a intersection, and we will do along a Y. So we're not doing a plane, we're doing an inclined plane. Let's come up to that curve there, and let's choose the point cloud. So let me show you the process. What it's found so far is we can see data points where this curve has hit the other curves. If I now ask it to update the intersection, it's interrogating the point cloud and finding a whole load more fit points to generate that curve. So you're not tracing that manually, you're tracing, the system is going in, intersecting the point cloud as if it was a surface and finding far more points to fit the curve with. And you can start to do some manipulation, some smoothing if you wanted to, but it's doing the hard work that you would typically do with measuring automatically, and then giving you the ability to decide whether you want to choose the curve or not. So where is the, there we go. If I create the curve, you can now see that that curve has been generated. It might have been automatically added to the model. You can see that it's got a bit of a shape that might not be perfect back there. What you see back here is we've got a lot of points that have been generated. And what I would have typically done is reduce the amount of points. I said earlier, having too many points is probably worse than having too little because you get a lot of unfairness. So I would have reduced that to a sensible number and added a bit of filtering, because it's quite likely that there are just too many points and the mathematics has got some over definition in that. And this is the process. So you have to define the boundaries because they're the hardest part. But once you've got that, the software will give you the ability to find the shape of the surface using the intersection curve, the intersection process that I just showed you.
Thank you. I really like this tool.
So I'm just looking.
Will be very useful.
You can see there are a number of videos on point clouds from conference, just from a demonstration there. So that will give you a little bit more information. So what we're talking of, a whole 40 minutes just talking about laser scanning.
So cool. Thanks. Thank you. Thank you.
Are there other questions? I don't think so. I don't think there are other questions.
Okay.
Again, Doctor, thank you so much for your presentation. It was really helpful. It is really helpful, this tool. And that's it. Thank you so much.
Thank you very much. If it would be useful to get into something a little bit more specific, I'd be more than happy to come back and do a particularly focused session. As you can see, PolyCAD is kind of covering quite a broad breadth. That's entirely up to the team you have there. So please feel free to ask for more.